This is Geometry, Chapter 10, Lesson 3. We're on page 392. All right, so this lesson is titled The Side Splitter Theorem. What the side splitter theorem says. Really, if I have any polygon, but particularly in most geometry textbooks, they're talking about triangles. If I have a triangle, and at any point I draw a line parallel to one of the sides, then it splits these sides proportionately, such that A over B equals C over D. All right, so let's think about why this would be the case. Let's call the big triangle ABC and the little one ADE. All right, so we're going to look at triangle ADE and compare it to the big triangle ABC. I should have written it AED. All right. Are there, in these two triangles, are there any parts that would absolutely be equal? David?
Their angles?
Which angles?
All of them.
Okay, how do you know? Okay, give me one angle and give me how you know it's absolutely equal.
Well, angle A has to equal angle A.
That's correct. Angle A has to equal angle A because that is reflexive. That is correct. Alexis?
It's on like ADE.
All right, so angle ADE
It's equal to
ACB. Why?
because like parallel lines make the corresponding lines.
Yes, because parallel lines form equal corresponding angles. So this angle corresponds to that angle. A is in both of them, so A obviously equals A. And so what do we know about the last angle? Angle AED. What does it equal in the big one? Angle ABC. Why? Landry?
Parallel lines form equal corresponding angles.
Same reason. They're corresponding angles. Okay, so every angle in this first triangle equals an angle in the second triangle. So what is angle ABC to triangle ABC to triangle AED? What is it?
Dilation.
It's a dilation. That is correct. It's just a bigger triangle. So they're similar. 100% of the time when you have triangles that are have all the same angles, then we know that their sides are proportional. That makes triangles that are similar. All right? So this side splitter theorem, it doesn't matter where you put the parallel line. I mean, I could draw the parallel line down here. And A over B would still equal C over D. Or even you could do a part over the whole equals a part over the whole. All right, so I could put part A over parts A plus B equals part C over part C plus D. Because those sides still have to be proportionate. Does that make sense? All right, so look in your textbook. On page 392. So they have drawn something similar to this. And they have given you, okay, there's actually a misprint in your textbook. It says that we will show that if DE is parallel to what? What does your textbook say? The bottom. Okay, that is not right. It's parallel to BC. Yeah. If it's parallel to BC, then that top section, AD over the bottom section, DB, has to equal the top section, AE over the bottom section, EC. And we can use that, then we have a proportion, and we can use cross multiplication to solve for the unknown variable. All right. So in algebra, this looks a little different. In algebra, we don't even have to have shapes. We can just have lines that are parallel. And we can say A over B equals C over D. We could even go down further and draw another set of parallel lines and label that E and F. You can do any of those. A over E has to be the same proportion as C over F. A over A plus B has to equal C over C plus D. You can use any of those proportions. All right, look what Theorem 44 says. It says, if a line parallel to one side of a triangle intersects the other two sides in different points, it divides the sides in the same ratio, the same proportion. All right, so that's what this lesson is about. Yes.
What page are you
I was on page 394.
on? I don't see theorem.
All right. It's on the top, Theorem 44, top page 393. Red letters.
Okay.
See it?
Yeah, mine just, I thought it said something different.
Oh. I probably don't use their exact words.
Yeah, naturally.
Okay.
Yeah, that's fine.
All right, look at the corollary on page 394. It says, if a line parallel to one side of a triangle intersects the other two sides at different points, it cuts off the segments proportional to the sides. Okay, so really this goes both ways. If we know that we have a triangle and one line is parallel to a third, then we know those sides are proportional. We can also go the other way. If it is given that those sides are proportionate, then what do we know about the lines? They have to be parallel, right? All right, so let's look at the worksheet that I handed out. All right, we'll look at the first problem. And then I'll let you guys work some of these. All right, so we're going to find the missing side. Here are our parallel lines. That's where the X is. This is 4. The total length is 14. All right, so can I know what this length is?
Yes.
What is it? 10, that's right. So what would be the proportion that I would write to solve for that question mark, that X? What would I write?
X over 15 equals 4 over 10.
Yes. Now how do I solve this? This was the previous lesson. What do I do? Yes.
Cross multiply.
Cross multiply. So I end up with 10x equals, what's 4 times 60? Then I divide by 10. God bless you, what's the value of x? X is 6. All right, Now, number 2 is a little different. God bless you. All right, now what is going to be the ratio that I write for this one? Elliot. 15 over 24 equals,
Question mark over 25.
okay, what goes with the 25 in the bigger question, and on this side?
It would be 25 over x.
It's 25 over x, got it?
How do we know that?
Okay,
'Cause that's-
15 is the piece, 25 is the piece, x is the whole, 24 is the whole. Does that make sense? They have to be corresponding. All right, what's 25 times 24? 600?
40.
Is it 600 equals 15x? And then you already figured out it's 40, right? Divided by 15, y'all are too fast. X is 40.
How do you know like what to put the numbers over?
Okay. Either I'm doing piece over the whole or piece over piece. Right, so let's just use ABCs. Here's one thing I need you guys to know. Look, it doesn't matter if I do 24 over 15 equals x over 25. Do y'all see this? Why does this matter? What have I done to get from here to here? I just took the inverse of both, right? Am I still multiplying 24 by 25? Yes. Am I still multiplying 15 by x? Okay. What matters is, let's use 1, 2, and the whole thing is 3, and 3, 4, and the whole thing is 5. All right? Let's talk about corresponding parts. All right? So on the bottom, 1 corresponds to, over here, 3. 2 corresponds to 4. I used 3 twice. Let's call this 6. 6 corresponds to 5. As long as in my rows, these parts correspond. So I could write 1 over 6 equals 3 over 5. I could write 1 over 2 equals 3 over 4. Got it? I could write 2 over 6 equals 4 over 5. So I could take any of these pieces over any other piece. I could do 6 over 1 equals 5 over 3, as long as we have corresponding parts.
That's my question. Like, if you just
Right, yes, yes.
Thanks, Russian.
All right, so let's work one problem.
Yeah.
Okay? I want to work one like is in your algebra textbooks. All right, so a lot of times they have a set of 3 parallel lines. And oftentimes they are fractions. So I'm just going to use fractions. I'm making it up. Okay. What would be the proportion you would write here? David.
2 over 3 over x.
So let's call it 2/3
2/3
over x
equals 5/3 over 7/3.
Yeah.
So
Alright,
would
so
it
what
be
do we do?
4/3?
Huh?
Never mind. We cross multiply. 2/3 times 7/3.
Which is what?
I don't know.
No, we can do it in our brains. 2/3 times 7/3. Multiply numerators, multiply denominators.
14 over 9.
14 over 9 equals,
5/3 times x.
all right, now, how do I solve for x?
Divide.
Do we divide fractions?
Multiply. We flip it. So
What do we call it when
reciprocal.
we reciprocal? We don't divide by fractions, we
We
multiply by the reciprocal. So multiplying by 3/5. Are these terms multiplied? Are these terms multiplied?
Yeah.
Before I multiply, I can.
Or
Did I get the
simplify.
Miss Haleyism?
Simplify.
Thank you! Before you multiply, you simplify.
So 1 and 3.
That's right, 1 and 3. All right, so what's the value of x?
14 to 20.
Yes.
I love math.